Now let's use Ekadhikenam Purvena to find out the division of a number in the form of 1 by a9. A number in the form of 1 by a9 could be 1 by 19, 1 by 29, 1 by 39, etc. So there are two ways of finding this division. One is obviously the division method, and the second is multiplication method. First we'll learn the multiplication method because it is easier to understand. So let's solve for 1 by 19. The first thing here is 19 minus 1, which is the difference of denominator and numerator, is equals to 18. So our answer will be in 18 decimal points, and after that it will start repeating. And the second thing is obviously the sutra, which is Ekadhikenam Purvenam. So the last digit here is 9, the previous digit is 1, so 1 more than 1 is 2. So the method goes something like this. Since the numerator here is 1, the last digit will become 1. And one more thing to note before we start the process is that in this multiplication method we start from right and we go towards left, which is unusual if you look at the normal mathematical way of solving problems. Anyways, let's start. So write the numerator, which is 1, here, the last digit. Now multiply this 1 with our 1 more than the previous one, which is 2 here. So if you multiply this 2 and 1, it will become 2. Now multiply this 2 here again to 2, so this will become 4. Similarly, now we'll again multiply 2 into 4, this will become 8. Now 8 into 2 is 16, so we'll write 6 here and 1 will be carry forwarded. So 2 into 6 is 12, 12 plus 1 is 13. So again 3 here and 1 carry forwarded. So 2 into 3 is 6 plus 1 7. 7 into 2 is 14, 4 here, 1 carry forwarded. 2 into 4 is 8 plus 1 9. 9 into 2 is 18, 8 here, 1 carry forwarded. 2 into 8 is 16 plus 1 17, again 1 carry forwarded. 2 into 7 is 14, 4 plus 1 15, so this is 5 here, 1 carry forwarded. Again 2 into 5 is 10, 10 plus 1 11, so 1 here and 1 carry forwarded. Again 2 into 1 is 2 plus 1 3, so this is 3. 2 into 3 is 6. 6 into 2 is 12, 2 here, 1 carry forwarded. Again 2 into 2 is 4 plus 1 5. Now 2 into 5 is 10, 0 here, 1 is carry forwarded. Now 2 into 0 is 0, so we'll stop here. And you also notice that we have covered 18 digits. Let's count them once. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So we'll put a decimal here. So the answer of 1 by 19 is equals to 0.0526 315 789 4 7 3 6 8 4 2 1, and again it will start from here, it will start repeating, so it will become 0 5 2 6 and so on. You can notice that this method is very easy to understand, but every time you'll have to solve for 18 digits, or basically denominator minus numerator number of digits. So now let's take a look at the other method. In that method we don't have to solve for this many decimal digits. Before we look into the division method, let's learn some small basics of dividing any number. So for example, if you divide 5 by 2, so 2 into 2 is 4 and 1 is the remainder. So here this 5 is dividend, this 2 is divisor, this 2 here is quotient, and this 1 here is remainder. Why we are looking into this is because this division method actually follows a quotient and remainder way of solving the problem. So let me write down the number, which is 1 by 19. Now in this method we'll start solving from left to right as usual. First we'll find out the ekadhik, which is one more than the previous one. So which is 1 more than 1 is 2. Now we'll take this 2 and we'll divide this 2 by 1, and we'll write the quotient here. We'll write the quotient after the decimal point. So if you divide 1 by 2, the quotient is 0 and the remainder is 1. Now what we'll do again is we'll divide this 10 by 2. So this 5 will be our quotient and 0 will be a remainder. So again take this in one pair and divide by 2. So this becomes 2 as quotient and 1 as remainder. Let's go along with this. 6 0 3 0 1 1 5 1 7 1 8 1 9 0 4 1 7 0 3 1 6 1 8 0 4 0 2 0 and 1 0. So if we notice, we can continue this further after 1 also, then it will become 0 1 5 0. So the numbers will start repeating from here. So this method is slightly difficult to understand than the previous method, but you can see you don't have to go from here to write the answer. If you want to write the answer in just 4 or 5 decimal point accuracy, you can just write 0.05263 and that would be the answer of 1 by 19. Let's take a look at again how this method is working. So what we are doing here is, first thing, we find out 1 more than the previous one. So 1 plus 1, which is 2. Second, we divide this 2 by numerator by 2, and then we write it like this: point numerator by 2, and we write it in terms of quotient and remainder. So 0 is the quotient, 1 is the remainder, and this goes along. Both these methods, division and multiplication, for dividing a number in the form of 1 by 9 are easier than our usual methods, and if you do practice, you'll be able to write the answer like in 5 seconds. Using Ekadhikena, we have seen how to divide a number in the form of 1 by a9. But this technique can also be used to divide a number, for example 2 by 19. The process is similar. First we have to find the number one more than the previous one, so this will become 2, and let's start the process. We'll divide this 2 by 2, so which will give us 1 as quotient and 0 as remainder. Now this 1 will be divided by 2, we'll get 0 as quotient and 1 as remainder. Now this 10 will be divided by 2, it will give us 5 as quotient and 0 as remainder. Now this 05 will be divided by 2, it will give us 2 as quotient and 1 as remainder. So the answer becomes 0.1052 and so on. Let's take another example wherein we divide something like 1 by 7. You notice that this is not in the form of 1 by a9 or let's say x by a9. So what we'll do, we'll convert this in the form of x by a9. So this, if you multiply 7 here and 7 here, this will become 7 by 49. So now this is something similar to x by a9. So this is 9, the previous one is 4, so 1 more than 4 is 5. Now let's divide 7 by 5. So we 1 as quotient and 2 as remainder. Now divide this 21 by 5, it will be 4 as quotient and 1 as remainder. Divide this 14 by 5, will be having 2 as quotient and 4 as remainder. Now divide 42 by 5, we'll have 8 as quotient and 2 as remainder, and so on. So the answer would be 0.1428 ... We have seen how to use the Ekadhikena Purvena to find out the division of 1 by a9. But now let's see why this process is working. 1 by a9 can be written as 1 divided by a plus 1 into x minus 1, where x is equals to 10. This can be further simplified as 1 by a plus 1 into x into 1 minus 1 by a plus 1 into x, which can be written again as 1 by a plus 1 into x into 1 minus 1 by a plus 1 into x raised to the power minus 1. Why minus 1? Because you have taken the inverse of this. So if you remember the formula of 1 minus 1 by n raised to the power minus 1, we can further write the equation as this: into 1 plus 1 by a plus 1 into x plus 1 by a plus 1 square x square up till infinity. Simplifying further, we get 1 by a plus 1 x plus 1 by a plus 1 square x square plus 1 by a plus 1 cube x cube, and so on up to infinity. Now here you can see that the a plus 1, which is actually 1 more than a, that is 1 more than the previous one, it comes in all the factors of this equation. So this proves the theory of why we are using Ekadhikena Purvena. This is the end of this lecture. Please practice it as much as you can. I'll see you in the next lecture.